So just by way of introduction, life cycles. So we've been around for nearly coming up to our 20th year anniversary, and we're about a dozen to 15 people, depending on which week you come in. And we specialise in environmental metrics. And we do that, we sort of work in whatever is required to help people measure what they're interested in. We work in that space. So sometimes that's making tools that they use, sometimes it's helping them do an LCA, sometimes it's a student visiting us, working with them, other times it's linking up with a company's own technical people or their consultants to work through an LCA. Because one of the things which is important to understand about LCA is it is a method and a knowledge area of itself, but it analyses other systems such as automotive manufacturing or construction or packaging. And if you're going to be useful in LCA of those things, you need to have an expertise also in that technical discipline. So hence we're always working with technical people and trying to take their technical knowledge and get it into the LCA realm. So this thing, the life cycle approach, what is it? It starts with this idea of tracking a production system from cradle to grave. And so, okay, don't just focus on the energy use or on the materials. Let's look at the full supply chain of how something interacts. And so that generally goes from some form of raw materials into manufacturing, through the use phase and into disposal. But as you can imagine, as you do that, there is one life cycle links to another life cycle. So somewhere in that use phase, you need packaging. So there's a packaging life cycle associated with the product life cycle. And there is some transport. And so the transport life cycle has its own life cycle of trucks and roads and things. And so you end up as a picture of a interacting life cycles. This is a life cycle model from SEMAPro, and you end up with like processes all over an economy as they are spread all over the world and all over Australia, interacting with one another. And it's not, people often think about, a beginning and an end. You sort of have a beginning where you have raw materials and an end. It's not a beginning and end, it's actually a network of interaction. You need pretty much everything to make pretty much anything, and so everything is connected to everything else. Which is why probably the thing before life cycle assessment was don't be nuclear, or don't use PVC, or don't do this, or don't use this chemicals. That was sort of the 70s environmentalism, was like working out what was bad and trying to avoid it. And we sort of realised, well, it's impossible to avoid anything in an economy that's so interconnected. And so we need to evaluate how to make sure that we're getting a net environmental reduction across all parts of the system, and not just trying to pick winners and losers and choose based on that. What life cycle assessment does to try and reach beyond the idea of winners and losers, good and bad, is we sort of break the system down into a model of how something is made. And so that's this life cycle model of raw material extraction. So we sort of refer to that things that we do as human beings, the economy, you might say, what our involvement, as the technosphere. So that's the technical realm of human beings doing stuff with stuff to make things. As you operate that, you extract stocks from the environment. There are things that are sitting in their natural place, in their natural form, and we take control of them and we bring them into the economy. We bring water in, we bring fuels in, we bring minerals in, we take land and we occupy it in a different format to produce what we want. And the economy also throws things back into the environment. So CO2, NOx and particulate matter go into the air, we have nitrates going into the water, we have pesticides and things going into soil. So there is a net sort of exchange of things coming into the technosphere and being released back to the ecosphere. So the ecosphere is nature, if you like. And we do that, we assess all of those things over a certain economic activity, such as catching an aeroplane flight, or making a cup of coffee, or staying in a hotel, or producing a kilogram of high-density polyethylene using the slurry polymerization process. You will come up with a long list of exchanges with the environment, these sort of inputs and outputs, typically maybe 1,000 if you're using our typical LCA software. And that's way too many, so then we link those flows these what we refer to as elementary flows out of this calculation to the things that we care about. Okay, so at the end of the day, what is it that we're really caring about? Do we care about the circular economy? No, we care about people being healthy. We care about species not being lost. We care about the environmental, cultural, social benefits that gives us. We have many things that we think about that use as proxies for that value, but what we really want to do is, we want to wake up healthy. We want other people to be healthy, and so we try and link these flows through certain impact categories that will affect those endpoints of human health, ecosystem health, and resource quality. So climate change is, of course, the largest, most existential threat of our time, and so that tends to dominate most calculations, and so it should. While we tackle that, we've tackled a range of other issues over the last 50 years, the smog in cities and ozone depletion and things, and we have had a significant dent on those sorts of things when we focus our energy, and hopefully we'll be able to talk in another 10, 20 years and say, well, climate change, we have a control in sight with that as we, with the effort that's going in at the moment. So that's essentially the structured model, and this model sort of up here and through here, you'll see there's no model here for naturalness or reusability or recyclability or biodegradability. What we do is we work out if it's biodegrading, is it contributing to any of these endpoints? If it's not biodegrading, if it's a piece of plastic lying at a beach, how does it contribute to these endpoints? So we focus on those, and that way we can sort of start to distill down between all these conflicting information that we're provided with, that your product should be reusable, recyclable, lightweighted, plastic-free and natural, and you should also make sure that the thing that's inside the package doesn't go off and has oxygen barriers and all those sorts of things, these sort of impossible tasks. So that's that's the general framework for life cycle assessment. Why would we do life cycle assessment? And it's a strange thing. I don't normally talk about why we do life cycle assessment, because by the time people have normally gotten to us, they must have worked something out, because they've rung us up and asked, we need a life cycle assessment, so we just go ahead, and then at the end they say, so what does this tell us? Oh, well, why did you offer, what do we do with it? And I thought that they had that in mind. But some of the reasons and I suppose the why, if you're thinking whether life cycle assessment is something you need, first thing is, it's the only way to demonstrate product environmental superiority. Anything else is sort of partial. So you might be dolphin free, or you might be plastic free or something, but that doesn't tell you whether the thing is sustainable or has a environmental superiority. We don't really have a measure of what sustainable is. I don't want to get too far into that debate. What makes it a good evaluator of environmental superiority is that it accounts for all parts of the supply chain, not just bits of them. It's focused on a common delivery of a common functionality. So if you say, do I want my coffee sweetened, and you say I can use cane sugar, I could use one of the fake sugars, Venti or something, then do I just count them gram for gram, or do I count them how they sweeten the product that I'm interested in? And so common functionality, common delivery of service is what we're looking at. So the LCA has this, will normalise everything to this functional unit, which is the thing that you want from the service you're asking for from that economic model. And that might be your transport requirements for a year, it might be a somewhere to stay for a night, it might be a structural member that can hold up a 4-story building or something like that. We also account for multiple environmental impacts. So depending on the form of LCA, typically you're trying not to just push your climate change impacts into being a water depletion impact, or your particulate impacts into a wastewater impact. You're trying to evaluate them all and make sure that they that if there are trade-offs between environmental compartments and environmental endpoints, that you're at least aware of them, and maybe you can minimise them, or maybe you can evaluate them, weight them against one another in some way. And the other thing which lifecycle assessment gives you is a set of standardised approaches. So when you do a lifecycle assessment and you tell one of your customers or the public or the government, they understand within a reasonable thing that, okay, lifecycle assessment, I know that it's got an international standard, it has certain rules, they can check whether you follow those rules, and you're working in a common language rather than trying just to, produce marketing gumph that doesn't go anywhere. And this is really important from the point of view of probably for the last 20 years you've been able to get away with some sweeping environmental claims. The ACCC and the public in general and NGOs are calling out sweeping claims of environmental superiority based on partial assessments. Second reason to do life cycle assessment is because of to get access to markets. So certain market segments in Australia and certain countries overseas are requiring life cycle assessment as a starting point for access to markets. If not an entire barrier, certainly getting into preferred markets is difficult without them. These include building and civil construction. So any of the sort of leading construction companies, particularly in commercial construction and in civil, roads and sewers and things, are all using rating tools that have environmental metrics in them. Those rating tools are referring to life cycle assessment studies in the upstream. So when you're looking to bring down your embodied carbon emissions or trade off the operational savings against the impacts, people are looking at life cycle assessment studies. And so if you're providing concrete into that market, every concrete producer in Australia is now done or doing an LCA to deliver into the building market. And there's going to push down from those big players, steel, concrete, timber, raw materials, into someone who makes guttering, someone else who makes void forms for concrete slabs. In the energy area, so biofuels, hydrogen, other alternative vehicles, it's a given that if you're coming forward with products in those areas, that you'll have a life cycle assessment, either for the government that you're seeking subsidies from, shareholders who are seeking to know that your product has a high quality outcomes from an environmental point of view. That really then leads on into any environmentally focused product. So if you're coming to market with a biodegradable super packaging product, people will want to see the life cycle assessment evidence around that. And then in the European markets, it will go more broadly than that, they have a plan to have a single European green market. They have a large set of databases is going to cut across textiles, electronics and furniture, and already been in buildings and fuels and other systems for many years, and agriculture. The third reason is to use life cycle assessment is because it's really hard to do environmental innovation. It's hard to get something to work through an injection molding machine that's contaminated. It's hard to make anything and do anything. And the last thing you want to do is get halfway through it or all the way through it and then find that the environmental advantages that you perceived are not true. And your shareholders, yourself, your customers, everyone feels cheated. You've wasted money and you've wasted people's time. And it gives the environmental innovation industry, if there is such a thing, a bad name that one week was saying, it's all about food miles, and the next week was saying it's all about water footprints, and 2 years down that was saying it's a circular economy. The market is you people just keep moving the posts, you don't know what you're doing. So having an integrated, thorough assessment sort of protects the industry, and whichever industry that, if you're in the environmental section of your industry, from this sort of fatigue of moving goalposts and things. We say, well, we're looking at a broad-based sustainability. And yes, when you tell your stories, lifecycle assessment's not a good storyteller. It's it's complex, it depends, it's got a lot of detail that you can never communicate to market, but it's the sort of thing you have in the background when someone who really wants to know, an NGO, the government, a competitor, so it's there for your robustness, and then you'll pick a particular story to talk about. You know, we've got a climate reduction because we're recycling this and we use this low impact material. So we sort of separate a little bit the storytelling to market, but we make sure that there's an integrated assessment sitting behind it. So how do we do life cycle assessment? This is getting to the sort of tricky part. There is, under the life cycle assessment standards, so there's a bunch of international standards developed by ISO, the International Standards Organization, and they sort of sit with all these other environmental standards. So if anyone's been involved in environmental management systems, that's ISO 14001, and then there are environmental audits in the 1420s, and the 1440s in this big long series of environmental standards is the LCA standards. And so they've been around for 20 years, they're relatively mature, and out of them comes a sort of 4-step procedure where you develop a goal and scope. Okay, let's just really frame up your question. What is it that you're wanting to answer? And let's say for today, we're wanting to answer whether these stainless steel jugs in the room holding the water are better off than if we were using single-use light PET water bottles. And you might say, well, that's a gimme, you know. The stainless steel jugs are definitely going to be better, but they are stainless steel. They're really heavy. They're slightly over-engineered. And you know, they've got to be probably washed in a commercial dishwasher out back after every use. So you know, it's not necessarily a gimme. If they so to give that as a scope, okay, that's our question. Other things that we would conceptualize in the scope is, do we have enough data? Do we know how to make those two things? Answer would be yes. We can work on what stainless steel manufacturing looks like, what an injection molding bottle of water looks like, what are the transport logistics of the water that's been bottled at Mount Franklin or somewhere in Tasmania and carted around. We can work through some of those. So that would be your sort of conceptualising what data you might need. And then we say, okay, how are we going to measure it? Are we just interested in climate change? Are we interested in other indicators such as, you know, smog or particulates or resource depletion? So we can frame around those. The second stage would be to build a model, and we might build a model if we get a chance of that exact comparison. And we have different software to do that. So it's obviously very data intensive, and so it automatically brings in the value of external data sources that have been developed by other people, so you can quickly answer certain questions. That gives us the data model, this inventory analysis. The third part is to actually do that calculation and work out, okay, what is the climate change impacts of different options? And the fourth is then to go into interpretation, which is, okay, what is it that we can conclude from our model? If the impacts of the stainless steel are 100 times better than the PT, we can probably feel pretty safe that the stainless steel is great. If the difference is sort of like 20%, we might go, oh, it's all going to hinge on how many times we reuse these stainless steel before someone drops it and dints it or gets corroded, or maybe it hinges on, you know, the weight of the PET bottle or something like that. So that's sort of robustness checks that happen in interpretation for you to say, as long as the stainless steel things are used more than 70 times, we are relatively confident that it will be environmentally superior to blah, 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 blah. So if you're opening up a hotel and you're going to have, you know, 3 guests a year, probably not worth investing in these stainless steel water bottles. Okay, so one of the really valuable tools, so before we get into how you do LCA from first principles, one tool that is really useful as a life cycle tool is understanding archetypes. So when you've done lots and lots of LCAs, I can sort of predict roughly whereabouts in the life cycle the impacts are going to be for any particular product archetype. And the value of that is you can then work out, is your innovation hitting the high point of the archetype, or are you fiddling around in one of the irrelevant areas of the archetype? And then you'll know whether you're sort of, likely to be addressing the impacts of interest. So the first archetype is a passive product. Chairs, tables, anything which doesn't consume energy during its life is relatively inanimate. So here we have most of the impacts will be in the raw materials. So that'll be in the production of steel, the production of aluminium, the production of timber, the production of resins. Around 20 to 40% of the impact would be in manufacturing. Injection molding, folding, welding, gluing, sewing, those sorts of things. Use, okay, maybe they've got to be washed, or pretty much nothing happens in use. And end of life, maybe a little bit of impact, but relatively inanimate. If you throw them into a big hole in the ground, doesn't look very good, but doesn't cause a lot of damage if they're not degradable. More than what we should be able to say from a circular economy point of view. If you could at least recover all the steel, then you'd end up slightly ahead. So that's like a passive product. If we look at a simple energy using product, so we've got a coffee machine at the back, which is slightly not simple. It's a little bit complex, got some electronics, but more or less anything's heating water, toasters, dishwashers, those sorts of things. Everything is about the use phase. Anything you do under materials and end of life are just fiddling around the edges. Still do them well. We have e-waste. We have a lot of now. I'm not sure if it's in Tasmania. I know in Victoria you can't throw anything with a plug into the bin. You've got to send it back. Now, the materials aren't really important, but it's all about operation. So that's the main focus area. Next one is a complex electrical product. So laptops, phones, maybe that funky coffee machine at the back. So here I'm starting to hedge my bets here a little bit, but the manufacturing actually ends up being a really big part of the supply chain, because you've got the clean rooms and micro processing and all of the sort of collateral that goes with that. The amount of material actually consumed is not that high. There are some definitely some social issues around the raw material production depending on the product, but the environmental impacts won't be as significant as the manufacturing. And then your use phase, the phone, for a phone, the use phase will tend to be lower. If it's got a big laptop with a big screen, maybe the operation phase gets a little bit higher. And end of life, again, probably should be a small benefit. I've got it as a small impact. If it gets recovered, we know through work that we've done for the ANZRP, the Australian New Zealand recycling program that recycles all the TVs and computers under the national scheme, that scheme more than pays for itself environmentally with the materials that are recovered, some in Australia and some internationally. Then we move into the heavy energy using product. So here we've got something, it's not electronic, but it's a building or a car. So it looks a little bit like our kettle, but there's a bit more oomph in the body of the thing. And this 80-20 rule, which we've had for a long time, it's often been a 90-10 rule. But come down here to Tassie, it probably becomes more of a 50-50 rule, because if a lot of this is electricity, your footprint for electricity in Tassie comes right down. So you might get to a 50-50 rule. And as we get renewable energy across other parts of the economy, we're hoping that will come down. But it's still not. Every time we do it, we think it will really come down. But and then there's maybe a service function. Looks at services have materials, but not so much. Usually, the sort of operation of the service has significant impacts. So there's sort of like group of archetypes. And I thought maybe in the break we might actually have a look and pick which archetype you think you might belong to and does it work. Someone asked where does I think there's a reason that food, I don't have food up there as an archetype because it's going to be all over the place depending on whether it's an apple sort of looks a little bit like this, a complex sort of food, bread will look a little bit like this because the baking and, if you've got a big cooking section, then that really gets up quite high. And then food and food waste has a significant impact. Packaging. Oh, I have one last one. There we go. So packaging, and I've got the red bar in sort of hashed. So packaging should look a little bit like this. Impacts are in materials. Conversion of the packaging is normally not so high. Definitely should get some materials back, given we have major recycling schemes set up to recover packaging materials. But if the packaging fails, the main impact of the packaging will almost always be the product that's lost. You get a leaker on a pallet of milk, the whole pallet of milk goes. So, packaging failure is catastrophic. If you buy a TV or a granite bench top and it turns up and it's broken, the whole thing's gone. So packaging function, we always like to remind ourselves that it's actually there for a reason. As they're not just doing it to fill up our recycling bin.
So is that why that one's shaded?
Yeah, it's sort of shaded. It's a opportunity cost or opportunity debit or something. if you think that it's something, if it fails, when it fails, and there is always failure packaging at certain levels, that's the impact. So that's a lifecycle tool in itself and really valuable. Something we use in lifecycle training. What happens once we get into what's a more serious LCA, for your product? We were this morning down at Sea Forest down near Triabunna, working on an LCA for them and their Asparagopsis. So that sort of LCA. So we have different sorts. There is lifecycle assessment for internal assessment. So if you're not wanting to communicate, at least yet, to the broader world, then that helps simplify your LCA somewhat. It can be simple or complex. You can follow the standards, but you can also be a bit more freeform. So if you're just trying to answer your own questions, we can work out when we're doing it which corners we can cut because they don't matter. Not for public release and low on documentation. So this sort of assessment would be sort of something you can do between a day and 2 months of work to undertake a lifecycle assessment of a product. It's good for understanding your impacts, sort of where you sit, maybe where you sit amongst competitors, what your absolute footprint is. You're able to explore options. How does your product change if you use different opportunities? Maybe you source your electricity from somewhere else. Maybe you buy replace that old machine that you were using. And it's a good way to prepare for, before you want to do external communications, to actually go through this process to work out what have I got to communicate, because some people often have an assumption that they've got this great thing they just want to tell the world, and when we do the analysis it's like, well, it's not as good as we initially thought. Sometimes it's even better than they thought. Sometimes there's a thing just off to the left that if you go down that path, we can have an enormous environmental benefit. I had one client say to me at the end of our presentation of our final thing about the LCA after 3 months, it was like, Sarah, is there anything where we're better? It was like, you should have come to me 3 years ago. For external communications, here we are following specific standards, and the standard will be, depending on which sector you're in, the standard will be dictated by, if you're in building, it'll be dictated by a European standard called EN 15978 and 804. If you're in biomass in Australia, the ARENA, Australian Renewable Energy Agency, have guidance for doing LCA for their funding rounds, and so that might govern what you're doing. So you'll have Usually some form of standard to follow. Some sectors not so much. Packaging, there's not really a single standard. It's a bit of a bit unregulated. Your LCA is going to be documented. So, you know, we're going to document what the assumptions are, the data are. People should be able to understand why the results are like they are. And this sort of documentation and third-party review really come out of the LCA in the 1990s being a tool for unscrupulous industries just commissioning LCAs and skewing the boundaries and the reporting in their direction, as people will do. So now quite strict guidance on how public declarations go. And this is sort of what the ACCC will be looking for anyone making environmental claims. The LCA standards aren't encoded into legislation, but they represent reasonable due diligence when it comes to environmental claims. So useful for accessing markets, declaring environmental performance, demonstrating environmental understanding. So I think anyone who's got an LCA is sort of demonstrated in the market that they take environment seriously and that they are constantly looking at the impacts of their supply chain and assessing those. So, you know, if I see a company and find out that they've been undertaking LCA, yeah, they did that when they started. So, okay, they've got a bit of a picture of what that thing, and again, a lot of it maybe isn't necessarily put in the public domain in a full way. And the last one, if you're trying to influence a debate, if you find that, so I find at the moment with the pressure coming on the plastics industry under marine plastics, macroplastics and microplastics, now where you sit on the how much of a threat you see that to be, the movement away from plastic products into non-plastic products has a real comes with a footprint. And so if you're trying to like educate that debate a bit further, then, you know, as a producer, whether you're producing stainless steel things or paper packaging, then you would want to produce LCAs and put them into the market to help guide that debate, whether it be at a sort of policy level, at a purchaser level. So, you know, the major supermarket chains are now starting to put in policies that will directly increase impacts up the supply chain, reducing the longevity of food on shelf because we're starting to put things in a paper carton instead of in a barrier plastic pack, which might be a good thing if it's sold correctly, but can have some unintended consequences. Just in terms of what to measure, we get asked a lot. What should we include? And I mentioned this idea of separate your story from your analysis. So climate change clearly is very, very important. There are a bunch of indicators that are commonly used in LCA, which I would like. These would be eutrophication, so algal blooms, photochemical ozone creation potential, so summer smogs in cities from vehicles and hydrocarbons, ozone depleting gases, acid rain, and I'd also put maybe even fossil fuel depletion in this category as things which I'm not very interested in. They're sort of half solved. They sort of all link back to energy and they all sort of follow climate change more or less because they're normally linked back to power generation or thermal fuel use. So they don't really add very much to your LCA. They often align the same thing and none of them are really big ticket items for most products. Maybe you're in agriculture, maybe eutrophication comes back in that list. Water scarcity, I would say it's so strongly linked to climate change because if you've got water, you can grow more things, you can sink more carbon. If you're short of water, then that becomes a real problem. So I think water scarcity is a really important. Land competition, they sort of sit in a triumvirate. If you've got land, you can sink carbon. If you've got water, you can sink carbon. If you've got high quality soil carbon, you can reduce soil. So they sort of part of the same thing. And then probably outside of those, in the toxicity area, Particulate matter kills or prematurely ends the life of 5 million people per year. Pre-pandemic, not sure after the pandemic. I know the savings initially from the shutdown of industry in China, its health benefits were far above the COVID costs in the early days. COVID caught up probably towards the end. But yeah, this is a major impact. It's very solvable. You just need particulate traps, and so it's a sort of bit of a developed world. Not enough pollution control technology, not enough regulation. But even in Australia, they estimate maybe 2,000 people will die prematurely because of particulate matter. And that's not sort of a theoretical model. It's based off of hospital admissions, high particulate matter days, correlation. So it's, and then the other one, which is probably for the future, is we do know that if you're sort of looking at the impacts of these indicators, particularly on human health and human well-being, we know that social impacts from supply chains and the severe underpayment of wages probably has more impact on people's health and well-being than all of our current environmental issues combined. Climate change is not all just about the current; it's about the long term. But certainly, there's a lot of interest in sort of leading European companies to start to include some of these social metrics and calculate the same things of disability adjusted life years caused because of inequities in supply chains. If you're just doing climate change, the good thing about climate change is it's connected to energy systems, and energy systems are connected to so many other things that if you solve for climate, you usually solve for a lot of other things. It's tricky to talk about which tools are available. So most of the because of the data requirements that sit behind LCA tools, they nearly all cost something. There's anything which is, you get what you pay for. Something like PK is $450 a month per user. If you're in construction, there's a fabulous tool called eTool, built out of WA, for modelling, whole commercial buildings. They have a second tool called Rapid LCA for doing houses. There's a thing called Earthster, which is a global tool that's free-ish. I think you can get in, you can do some modelling. You'll get stuck eventually. You'll want some data that it won't give you, and you'll have to help buy some data. And then there is, at this link, the EcoInvent. If you go to the EcoInvent, is one of the major data providers globally. It's a big Swiss organisation. And because they provide this huge underlying database, there are like 100 tools that are built on top of EcoInvent. So if you're going to build an LCA tool, and all these tools use bits of EcoInvent, you can go there and there's a list of all the different tools, and there are some free-ish tools that come out of there for in different sectors. But none of these two here are the two Australian ones that I sort of know of. And then below those simpler tools, then there are like really detailed tools, things like SemaPro and Gabi and OpenLCA, which is like someone having to open up GIS software just instead of Google Maps. You've got the wrong tool if you're starting to go into that. I think that's about it.